Hey everybody, welcome to the Texas Diesel Tech. Today we'll be going over how a relay functions. This right here is a simple 4-pin relay. There are also 5 pins, but we'll get into that later. So let's go over how everything starts out. So this is a typical wiring diagram, and in every wiring diagram you'll see the power starts at the top and the ground or control will end most likely at the bottom. That's typically no matter what. So right here, this box just represents your fuse panel that has a bunch of pins in it to where your fuses will plug into. Now you have your fuse that comes out and then supplies power to pins 85 and pin 30. So you can have it one or two ways. You can have it like this, so where there's one fuse supplying one side of the coil of the relay, and the control side, or you can have it to where there are two separate fuses. So there could be one coming out from here, a separate fuse all alone going to pin 30. Now the way this works is pin 85 and pin 86 are your coil. So what happens is when you put power right here on one side of the coil, put ground on the other side, it makes electromagnetic field, which makes a magnet. So this is metal, makes a magnet. This contact right here, going from 30 to this pin that's internal, which can be also your 5th pin, if this was a 5-pin relay, which is just where the contact rests. It's spring loaded, goes back and returns to this pin. Well, when 85 and 86 make this magnet, it pulls this metal switch contact over to pin 87 right here. And in that, it completes the circuit. So the power goes from here, goes through here, this energizes, and the power comes out to 87, going to your starter solenoid. This circuit right here I just made, it's a simple ground controlled relay starter circuit, for a lot of different applications. They're for trucks, 18 wheelers, whatever. I've seen them like this on multiple trucks. So uh, typically, every relay, 85 is going to be power, 86 is going to be ground. That can be switched, seeing as how this doesn't have a diode in it. This is a non-diode relay, which we'll get into another video of a diode relay. So these could be switched. I could have ground on this side, power on this side. It really doesn't matter as long as you're getting power and ground to the coil. Now, pin 30, that's always going to have a power coming from a fuse or some sort of power source, no matter what. That never changes. Pin 87 is always going to be your control pin. That's always going to go to whatever component you're trying to control. So right here, we're trying to control the starter solenoid. We're trying to send power to it to engage the starter. So you can determine what type of circuit you have by seeing which one's constant. Because if I have, so in this circuit, I have a constant power. I know it's a ground controlled relay then, because the ECM is going to send ground whenever it gets signal from whatever else it needs. It's going to send a ground signal to this side of the relay, energizing the coil and sending power to the starter solenoid. Now, if I had a constant ground here, then the control would be a power control. But 9 times out of 10, well, it depends. But majority of the time, you're going to have a constant power. 85, constant power. 30, 86 will be ground controlled, and 87 will go to whatever control device you're trying to control. So if we wanted to test this, which I'll post another video on actually doing it hands-on, this is kind of just the fundamentals of it. We could take a test light, which I'll explain how to use, and go check for power here at 85 and check for power here at 30. If we know we have power here at 85 and at 30, then we know this side of the relay is good. So if for some reason, say, the starter wasn't working, the starter solenoid wasn't getting a signal, it wasn't turning over, engaging, we would check, like I said, 12 volts here, 12 volts here. Then we would check for a ground signal on this side. So if we have all this, then we can eliminate that this side of the circuit, all this is good, and that our fault would be between here and here. Personally, I like to use a power probe and everything, because what I would do personally is go to this side of the relay and put ground. Make sure I hear it click, because every time it engages, you're gonna hear it click. You can feel it. You can actually put your finger on it and everything like that. So we'd hear it click, and then I would see if it worked. If it didn't, what we could also do is use a power probe, put ground here, and then checked for power output right here. Because sometimes these contacts can wear and burn out, and the relay can work, but it's not going to transfer power due to the dirty contacts in here. So I hope this helped anybody out that needed some more understanding of how a relay works. Like and subscribe to the video and hang out for more. Thanks. Have a great day.